So in this video, we are going to learn a new concept like how to detect cycle using Floyd cycle detection. Okay, so what's procedure in this cycle detection method? And earlier we all cover the basic cycle detection approach, but this approach is optimized approach ever. So in this approach, we can use two pointer. So first one is slow pointer and second one is fast pointer. And initially we will initialize both pointer with head. Alright, like in this example, we initialize slow and fast pointer with head. So this look like this. And every iteration we operate this operation like we increment the slow by one step and we increment the step of fast by two step. So every iteration it will be follow uh, follow these two changes. So if we iterate first time, so slow pointer will move to 20 and fast pointer will be move to move to 15. And after next iteration, S pointer will be moved to 15 and fast pointer will be moved to 25 because it's takes two step. And after that, if we iterate next iteration, so S will be pointing to 20 and fast pointer will be pointing to 15. And we also we will check whether fast pointer is equal to s a slow pointer or not. So here it is not. So we will continue our process. So we will increment the slow pointer by one step and fast pointer by two step. So at that node at 25, here slow pointer will be equal to fast pointer. It means uh, the node 25 will create a cycle, and we clearly see the cycle in the given example. This is a cycle. Okay? So in this approach, we can do this thing. So let's also we'll discuss with code and just dry run to better understanding. Okay, so here the slow pointer is at 10 and fast pointer is head, and similar we will use initialization method. And in the while, this is a important concept and important condition for this problem. Why we write this condition? Because like when we have two node and we are reached at the 20, and then if we apply this this condition, so after that this condition, this will be changed fast next to next, but here the fast next is already null, so it is going to out of boundary, it's going to overflow. So that's why to avoiding this such type of condition, we will we will we will make a boundary condition in while loop. Okay, so and when we this is a two basic simple step, we will uh, we will increment the slow pointer and fast pointer until if any any time if fast is equal to slow. In the earlier case, uh, fast is equal to slow. So in this case, fast is equal to slow. It means it create a cycle. So we will return true. And if if you don't get any cycle in this given linked list, so we will return simple false. Okay, so the next problem uh, like comes in everyone minds how this algorithm is work. Okay, so let's uh, jump to the explanation part, like how this algorithm is work. So there are many points I have written down here. So first point is fast pointer will enter will enter always before the slow pointer in the loop. Like we have a loop in this way. This is a loop. So in this case, fast is enter before because this is a obvious things because in every step we will jump fast to a step, but for the slow pointer we will jump only one step, so that it's obvious fast pointer will be enter in the loop first. So let's in the starting both pointer is here s and f, and after the first iteration slow is going to this and fast is at this one. Uh, so we clearly see that fast is enter the loop before s enter in the loop. Okay, so this point is, I hope this point is clear for all of you. And let's jump to the next point. In this point, uh, we will take a k distance. Okay, and let's fast pointer k distance of slow. Okay, so in this case we will assume k is a distance between fast and slow. Like if you take an example, to take an example, like this is an example. Okay, and initially fast and slow is here. Fast is here and slow is here, and every step. So now k value will be equal to 0 because the distance between slow and fast pointer is 0. So after first iteration, s will be at this node and fast will be at this node. So what is the distance between them? So distance between them is now 1, and you clearly see that it's increment by 1, and then we will also move to the next s2 next and f fast pointer to fast next to next we will jump to the 2 step. So fast is here and slow is here. So distance between slow pointer and fast pointer is 2. So you also clearly see that the distance will be increasing one by one. Okay, so I hope this point is clear to all of you now. Okay, so in the third point, it said that distance is increasing one in every iteration. Yeah, that's true. We will earlier we will take an example for this condition. And the most important condition is if distance becomes length of cycle. If they meet, like in this case, if you take an example like this linked list, okay, so if they meet, like we we know that they will meet at that point. Okay, so at that point, so number of k, like k will be distance between slow pointer and fast pointer. Okay, so it's denotes the length of cycle, like it's denotes of length of cycle. Okay, so here length of cycle is 1, 2, 3, 4, 5. So length of cycle is 4. So in this case, if we move to the uh, fast pointer to a step, so in this case we increment the distance between fast and slow is 1 by 1. But if there is any cycle, okay, so if there is any cycle, it means slow is equal to fast. So in that case, we will return true, and otherwise not. So this is a code. I'm also uh, just erase the marker so it will be vis- visible for all of you. So this is a basic code. Okay, so this is a basic code. In this code, let's discuss the code form here, because in that code I will forget to consider the base cases. So here base cases is here. If head is equal to null, so if there is a no head, so in this case there is a no cycle, so we will return false. And initially we will assign head into slow and fast pointer. It's obvious. Okay, and this is a while loop, and in this while loop we will check two condition. It's avoid to overflow, and for every iteration we will do perform this operation. And during this operation, if any point, any node, if we get fast is equal to slow, so it means it's clearly so that there is a cycle will be present in linked list. So in this case we will return true, otherwise false. I hope you got the concept behind this question. And if you are new to my YouTube channel, so please kindly subscribe my channel for the this type of important video which are uh, which are helpful for your next upcoming placement session. And I will put uh, every day a single problem solution, and I will follow this lead code problem. So we are at the link list. So we will first finish 5 questions and then move to the stake. And if you are new to my channel, then please subscribe it and also share with your friend. Okay, thanks. See you soon.